Draw the Lewis or electron dot structures for the following compounds. Well, if we look at CH4, alternately called methane, we can see that we have 1 carbon and 4 hydrogens. The 1 carbon brings 4 electrons by itself to the party, and each of the 4 hydrogens brings 1 electron. So we have a total of 8 electrons to work with. We start with the carbon in the middle, surrounded by the 4 hydrogens of the formula, and we place 8 electrons around the central atom. We've used all 8. Every atom has its complete octet, remembering that hydrogen is happy with 2 electrons because its row of the periodic table only has 2 elements. For the next one, we're looking at SO3. It's important, as an aside, that this is not sulfite. If it were sulfite, it would have a negative 2 charge listed. It's sulfur trioxide, uncharged neutral. So we look at the sulfur, and sulfur is 6 columns from the left-hand side. It brings 6 electrons to the party. We have 3 oxygens. Each one of these brings 6 electrons as well. And 3 times 6 is 18, plus 6 is 24 electrons total. We start with the sulfur in the middle, surrounded by 3 oxygens. 8 of these 24 electrons will go around the sulfur, leaving 16 electrons left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and this last oxygen is shy a few electrons. But I have a lone pair, a pair of electrons that's not involved in bonding, that's sitting on the sulfur. Let's put them to work. If I move that lone pair, between the sulfur and the oxygen, they now count for both atoms, making the oxygen happy with a completely full octet of 4 shared electrons and 4 electrons within lone pairs. And this would be our final answer. Now, if you drew this so that the double bonds may have gone in a different direction, something like that without the weird backwards S. This would also be, or if the double bond went down, the variations called resonance structures are also completely acceptable. As long as each element has 8 electrons and we do not go beyond the total electrons that we have to work with, we should be okay.